In this video, let us see Runge-Kutta method of second order. Let us consider the differential equation y dash of x is equal to f of x comma y with the initial conditions y of x naught is equal to y naught. Here the formula for Runge-Kutta method of second order is y1 is equal to y naught plus delta y, where delta y is equal to k2. So to find out k2, here we want to first find out k1. So the formula for k1 is equal to h into f of x naught comma y naught, and k2 is equal to h into f of x naught plus h by 2 comma y naught plus k1 by 2. So after calculating k1, we can find out k2. Once you have calculated k2, we can substitute in place of delta y. So finally y1 will give you y naught plus delta y as the answer. So here if you notice this formula is similar to, that is, if you substitute directly delta y is equal to k2, and in place of delta y if you put h into f of x naught plus h by 2 comma y naught plus k1 by 2, this total formula is nothing but it is the same as modified Euler method, so that both are the same. So here it is called as Runge-Kutta method of second order if you use the notation k1 and k2. So now let us move on to the problem. So first question is, using Runge-Kutta method of second order, compute the value of y of 0.1 and y of 0.2 for y dash is equal to x plus y square with the condition y of 0 is equal to 1. Let us see the solution. So here first let us write what are the given function. So here the function f of x comma y is equal to x plus y square. And what are the given condition? Y of 0 is equal to 1, which means that x naught is equal to 0 and y naught is equal to 1. And moreover here we want to find out the value of y for given x is equal to 0.1 and 0.2. So already what is given here, 0 and 1. So when x is equal to 0, y takes the value. This we are taking it from the initial condition given. Apart from this, we have to find out what is the value of y at 0.1 and what is the value of y at x equal to 0.2. So here we want to find out at x equal to 0.1 what is the value of y. Similarly, when x is equal to 0.2, what is the value of y. So this is our question. And then if you see here, h is not given in the question, but in the formula we are having h. So how to consider h here? So here we can notice the value of x, how it varies. Okay, here the values of x varies by 0.1. So here we can fix h is equal to 0.1. So here by taking h is equal to 0.1 and assuming x naught is equal to 0 and y naught as 1, now we can calculate what is y1. So this will be considered as x1 and this is x2. So the corresponding value will be y2. So now our aim is to find out y1 and y2. So now let us start the calculation. So first to find y of 0.1. So to find out y of 0.1, first we should know what is x naught value and what is y naught value. X naught is nothing but 0 and y naught is nothing but 1. So using this, first we have to calculate k1 and k2. Since it is a Runge-Kutta method of second order, we have to calculate k1 and k2. So here let us consider k1. We know the formula for k1 is f into f of x naught comma y naught. So this is equal to h is nothing but 0.1 we have considered, and f of x naught is 0 and y naught is 1. So already we have assumed f of x comma y is equal to x plus y square, which is given in the question. So here if you put x equal to 0 and if you put y is equal to 1, the answer will be 0.1 into 1, which is equal to 0.1. So the k1 value is equal to 0.1. Now to find out k2. So k2, the formula is h into f of x naught plus h by 2 comma y naught plus k1 by 2. So this is equal to, again h is 0.1 into f of, we have to put x naught as 0, h is 0.1 divided by 2. So after calculation we'll be getting it to be 0.05, and then y naught plus k1 we have to take it as 0.1, y naught is 1 and k1 divided by 2. So after simplification, this gives you 1.05. So now substituting the value, this is x and this is y. If you put in the function x plus y square, calculating and multiplying by 0.1, we will be getting the answer as 0.1153. Now we have to find out y1, which is equal to y naught plus delta y is the formula, where according to the formula delta y is nothing but k2. So finally what will happen, y naught is nothing but 1 plus delta y is nothing but k2, k2 is nothing but 0.1153. So the final answer is 1.1153 is the answer, and this is y1. y1 is nothing but y of 0.1, which is equal to 1.1153. So this is the way we are calculating y of 0.1 using Runge-Kutta method of second order. Now let us find the value of y of 0.2. So to calculate y of 0.2, what we have to consider is, already we know that h is equal to 0.1. Apart from this, here x1 is 0.1 and y1 is 1.1153. Is it clear? So because assuming that x naught is equal to 0 and y naught is equal to 1, in the first step we calculated y value as 1.1153, that is y of 0.1 we calculated. So this 0.1 should be considered as x1, the next value to x naught, and y1 will be the next value of y naught, which is 1.1153 we calculated in the previous step. Now using these values, we are going to now calculate y of 0.2. So again we have to use the same formula, that is k1 is equal to h into, now the formula should be x1 comma y1. Is it clear? So this is equal to, h is fixed always, so h is 0.1 and f of x1 is 0.1 and y1 is 1.1153. So now what we have to do here, 0.1 into f. Here what is the function f? F of x comma y is the function x plus y square. So here x is 0.1 plus 1.1153 whole square. So this we have to calculate it. So that 0.1 into this value will be 1.344. So now multiplying by 0.1, the answer is 0.1344. So this is the value of k1. Next we have to find out the value of k2. K2 formulas, h into f of x1 plus h by 2 comma y1 plus k1 by 2. So now what we have to do, h is 0.1 into f of x1 is 0.1 plus h is 0.1 by 2 comma y1 is what, 1.1153 plus k1 is what, 0.1344 divided by 2. Is it clear? So this is 0.1 into f of this calculation, after calculation it will give you 0.15, and then this after calculation it will give you 1.1824. So this is x and this is y. Again you have to put it in the same function and then multiplying by 0.1, we will get the answer as 0.1548. So this is k2. So since this is k2, delta y is nothing but k2, which is equal to 0.1548. So finally what is the value of y2? y2 is nothing but y1 plus delta y. So what is y1 here? y1 is 1.1153 plus k2 is delta y, that is 0.1548. So this is equal to, the final answer is 1.2701. So finally here we can conclude that y of 0.2 is equal to 1.2701. 0.2701. This is the value for y of 0.2. Hence, therefore, we have calculated the value of y at 0.1 and 0.2. So, first we have calculated in the first step for 0.1. The answer is 1.1153, and in the second step we have calculated for 0.2, that is 1.2701. So, both we have calculated by using Runge-Kutta method of second order.